Alright, now let's look into this one. So we are given the square root of 5 all to the power of x, remove the cube root of 2 all to the power of y, which is equals to 17. Then we are told that x and y are contained, or rather they are elements of natural numbers. So we want to determine the value for p, of which p is nothing but the product of x and y. So we just need to know what is x and what is y. Okay, so let's look into that. So before we even go further, we are just going to look into few laws of exponents and radicals. All right, so I'm not going to highlight all of them. I'll just need the ones that are going to be useful here. So we know that if we have a base, let's say a to the power of b all to the power of m, we can express this as a to the power of b m, which is the same as a to the power of m then to the power of b. Right, so we'll need that. Then we'll also need this uh, property of radicals to say that if we have this radical with index n and the radicand which is the power of a there, we can express this as x to the power of a all over n. Right, so these are the two main properties from exponents and radicals which we are going to apply in our problem here. Right, so I'm going to just have the square root of 5 then to the power of x, remove the cube root of 2 then to the power of y, like that, which is equals to 17. Then I can express this as 5 to the power of half, since this is a square root, so my index there is 2. So I can have 5 to the power of half all to the power of x, and this one, my index is 3, so I can express this guy as 2. What is my radicand? Is 1 there, so I can have 1 over 3, then all to the power of y equals to what? Equals to 17. Okay, then from here we can apply that property, which is this guy here, can multiply the power, so I'll have 5 to the power of, I can say half multiplied by x, that will be x over 2, then minus, I do the very same thing here, base 2 to the power of y all over 3. So this is going to be equals to what? It's going to be equals to uh, uh, 17. Right. Okay, so now before we proceed, we'll have to use a small trick there to say we know that 1 squared is 1. We also know that 2 squared is 4. We also know that 3 squared is 9. We also know that 4 squared is 16, and we also know that 5 squared is 25. Alright, so I'm looking into this denominator here to say, okay, fine, how about how about uh, I more like take this guy here as, okay, I see I have base 5 the power of x over 2, so I'm just going to use the trick behind there and say that this is the same as the 5 to the power of x over 2, remove your 2 y over 3, then I'll use the very same trick this side. So if I take 5 squared and remove 2 cubed, this is something like your 25 minus 8, right? This is 25 minus 8. And what is 25 minus 8? What is 25 minus 8? So let's double check that. So 25 minus 8, that is going to give us the 17. So you see, so this is just the small trick behind. That's the small trick behind which you can try to play around with. Otherwise, it's gonna be a problem now to try all this, because I wanted to take the squares here, then take the cubes up until 5, then we check the ones that when we subtract they give us 17. But so I'm just saving time, right? So from here we can see that these two quantities are said to be equal because of the equals to sign. So if 5 is equals to 5 and 2 is equals to 2, this implies what? This implies that x over 2 should be equals to 2, and y over 3 should be equals to 3. Then by using your cross multiplication, x should be 4 and your y should be what? Your y should be 9. Therefore, remember we are looking for that guy. Therefore, you can say P is equals to the product of x and y, that is 4 multiplied by 9, which is nothing but 36. So voila, that's how you work out that guy there.